Hello viewers and welcome back to Fofana Maths class. Before we begin today's lesson, I would like to express my profound gratitude to my followers, both family and friends, especially to my elder brother Muhammad Awali Fofana and my other brothers and sisters. To may the Almighty bless all of you for supporting me in this work. And to my friends, those who motivate me, those who comment and tell me that Fofana, what you are doing is a great job, keep it up. Charlie, you don't know how much this means to me. It means to me a lot. It motivates me, it encourages me to keep the work going. All right, so may God bless all of you. May God bless all of everybody who makes sure this initiation is a success. Whoever has a hand in making this initiation a success, may the Almighty richly bless all of you. Not forgetting my #1 cameraman, the one who makes sure that this video is recorded, the one who has a hand in recording this video, who is in the person of Abdurrahim Abdul Samad. May the Almighty bless you too and then grant you all your heart desires. Now, the topic that we are going to look at is calculus. And the first thing, the reason why we are looking at this topic is, calculus embed a lot of mathematics topics in it. Okay, so before a question will be given to you, what you will realize is there is a certain mathematics topic that you will have to deal with before the calculus itself comes in. For instance, some time ago or in my previous audios, I solved one question which has a topic called set in it. So you'll have to resolve the set or rationalize the set before the calculus aspect comes in, which is the integration. Okay, so here we are going to look at the topic calculus, and then the first thing that we're going to look at the calculus is limit of a function. Okay, when we say a limit of a function, what does it mean? And then I've given this short note to explain the limit of a function. The reason why I gave this note is in case someone doesn't understand maybe a word that comes out of my mouth, or a certain phrase or a certain statement that comes out of my mouth, and the person can refer to the short note to better his or her understanding. Now, for a given function f of x, x approaches a is what we are going to look at the meaning. Okay, x approaches a means the behavior of f of x for values of x. Okay, so the first thing that I want to look at the limit of a function is when you have something like this. Okay, when they tell you x is then a certain arrow which is pointing to a, what it means is x is approaching what? A. All right, now it means that the behavior of f of x for values of x. All right, so it means that a function in x will be given to you, and then values of x will also be given to you. So when you substitute those values of x, which is the a, into that particular f of x, what will be the behavior of f of x? Okay, so will f of x increase or will it what? Decrease? That is what we are going to look at. All right, so x approaches a is just telling you the behavior of f of x for values of x around what? A, around the value that will be given to you. Now we have an example here, which is what? If f of x is equal to 3x plus 2, around x is equal to 4. All right, so when you have a function which is what? F of x, which is equal to 3x plus 2, 3x plus 2, and it is the x is equal to what? 4. All right, so this f of x is around x is equal to 4. What will be the behavior of f of x around what? X is equal to 4. So now we will give values which are greater than 4 as well as values which are what? Less than 4. Hence we will form a table and then look at the meaning, okay, or look at the behavior of f of x around what? 4. Now the thing is, with the first table we have values of x which are reducing and approaching 4. Okay, and then in the second table we have values of x which are increasing towards 4. All right, now with the first value, when you have 8, this is when you insert it or when you substitute it into f of x, this is the value that you'll be having, okay, which is 26. All right, with the second one it will be what? 23. The third one, which is 6, the value will be what? 20. So you will realize that the f of x is also approaching a certain value. All right, as the x is approaching 4, f of x is also approaching a certain value. Okay, so here values that are greater than 4, but they are also reducing towards what? 4. All right, now the second table too that I said earlier is that the x has a value which the values of x in the second table is less than 4, but they are also increasing, approaching what? 4. Now this is what happens when you insert those values into f of x. The solutions that you will be getting, you realize that they will also be increasing whilst they are approaching a certain value also. All right, so if f of x, if x is equal to negative, you have a negative number 0, you realize that the numbers are increasing and they are heading towards a certain number. Now let's see from the first table, if the f of x should get to 4, what will happen? If in the first table we have f of x here, we have x to be 4, and then in the second table too we have x to be 4, what will happen? Since they are both for the same function, when you insert 4 into the f of x, what you will be having will be 3 times 4 will give you what? Will give you 12 plus 2, you have 14. So it means you have 14 here and then you have 14 here. So what it means is, as over here those values they are approaching 4, it means this the f of x is also approaching what? 14. So that is the behavior. Okay, so as x is reducing from the highest and then it is approaching what? 4, then f of x is also approaching what? 14. The same way in the second table, if f of x is also x is also approaching 4, meaning they are increasing from the lowest to 4, you realize that f of x is also what? Increasing towards 4. Okay, so that is the behavior. That's what it means by what it means by what do you call it? That's what the whole of what x approaches a means. Okay, in short. Now the next thing that we'll look at is when in this case, if x is approaching 4, okay, then you realize that f of x is also what? Approaching what? 14. All right, so in notational form, okay, in notational form, instead of writing them in this way, as f of x is approaching what? 14, as x is approaching 4, then f of x is also approaching 4. This is written in notational form as the limit, okay, of f of x as x is approaching 4, then is what? Equal to 14. So this 14 here is the limit as f of x is what? Approaching 4. All right, so this I will give one short example, then we see limits of say a function which is say 4x plus 5 as x approaches 2. Okay, so what will be the limit of this function? All right, so it will be equal to, all you need to do is to substitute the x into the function. Okay, so we have x 4 times what? X, which is 2 plus 5. All right, so we'll be having 4 times 2, we have 8 plus 5, and then your answer 8 plus 5 will give you 13. All right, so this is a simple example of f of x. So in my next video we'll be looking at standards of limit of a function. Okay, when we are asked to give limit of a function, right, maybe a number, then we have to look for the limit of a function. It will take us a whole lot of time because we will have to form a table, then look at the numbers one after the other. Okay, arrange the numbers, those that are more than that number and then approaching it downwards, and then those that are less than that number and then approaching it upwards, before we get to a number like 4 here and then 4 here, before we realize that the limit of that function will be what? 14 and then what? 14. So there is a short way that we use to find that, which is the standard. We have standard of what? Limit. So in my next video we'll be looking at what? The standard of the limit. Have a nice day.